Hello, and welcome to the Specialty Matcha Podcast. My name is Ryan. This is my co-host Sungjun,
Hello, hello.
and we're the co-founders of Senko Matcha Products.
Yeah, so we launched this podcast to discuss our learning journey in matcha, share startup stories, and interview experts.
We're happy to have on Arby Avanesian, who is the sole founder of Empirical Water, which is an open-source, nature-inspired mineral water for brewing tea. You may know him as the author of the tea blog Empirical Tea, and he has identified that brewing water is the main bottleneck that's pretty much affecting everyone who enjoys fine tea. He wants to solve that problem for good, even if it means giving away all of his recipes and formulation techniques. So thank you for coming on, RB. And we also thank you from the broader tea community for doing all of this research and publishing it and also constantly iterating on it. Like there's one thing to do a bunch of testing and have sort of this static knowledge and wisdom, but you keep making different iterations and sort of explaining to people in the release notes of each of your recipes, like what you've changed and why. And like those like first principles mechanics I think are really helpful just to the whole specialty tea community in general. So thank you.
Thank you for having me on here. I don't often get the opportunity to speak like this publicly on, my favorite topic. So I'm really grateful to be on here.
Happy to have you, and thank you for saying yes for a new podcast. And we're really lucky to have experts on like really critical topics, especially for tea. Water is what, like 98%, or tea is 98% water, and it's like one of the most overlooked things.
Yeah.
All right. So diving right in, for our listeners, can you explain a little bit about the importance of water in brewing tea and preparing matcha in general?
Yeah. So just a disclaimer before we get started. I'm not a chemist. I actually dropped out of my biochemistry degree once I realized that I could pretty much figure out everything I needed to know by, consulting like academic literature as necessary, but really predominantly relying on personal, real world, subjective experiences as well as the subjective experiences of everyone else who is into tea and gets the opportunity to taste my water and like evaluate it for themselves. So that just as a disclaimer that I'm not a chemist. This is not based on um peer reviewed journalism. This is like one person's opinion, and I just want to make that clear.
Got it. Yeah. Thanks for being upfront. And I would say, even on the academic literature side, there's very like little application based research, right? Like you could have very niche people talking about like certain types of extraction theory with different water minerality, etc. But like I feel like very few people do this from end to end. From like how does an organoleptic outcome or sensory or flavor outcome happen because of the chemistry that you're tweaking. It's like you don't often sometimes you see that in different parts of the food industry, but for brewing water and specialty tea, it seems like we're really on the edge of knowledge that's readily available. So I think
Yeah,
like your approach being very empirical makes a lot of sense.
yeah. I did want to mention that I think that academic literature tends to be pretty narrow scope because it's really hard to design a study that is going to be in any way comprehensive to exhaust all the different variables. So what they have to do is they have to focus on one like hyper specific outcome and test for that. Um, and that's really hard to interpret in a practical way if you're not yourself a chemist or somehow in the know about those things.
Makes sense. Or maybe any application based research that's more holistic is probably kept behind closed doors. I imagine the largest, like the beverage companies, like all the like the Japanese ready to drink green teas that you see out and about. Like I doubt that they're doing that much knowledge sharing. I wouldn't if I were them.
Yeah. So to answer your original question, so I think of the role of water as, well, basically it's a job. Its job is to work its way inside tea leaves, capture valuable stuff that we want to experience, and then deliver that stuff into your teacup so that when you drink it, it's, interacting with your mouth and throat. your taste buds. So water is the solvent, and the tea leaf, is the solute. Now, we're on a matcha podcast here, so it's like matcha is a little bit different than most tea because it's like a suspension. You're not like separating the stuff that you're extracting from the leaves themselves. Really, you're gonna be consuming all of that soup. You're gonna be consuming all of it. So that kind of affects things, and we'll get into that. But in general, the principle applies. The job of water is to dissolve like flavorful compounds from inside the tea leaves, bring that out into the drinkable tea, and basically ignore or mask the stuff that you don't want to taste. Because all tea leaves have enjoyable qualities as well as some undesirable qualities.
Makes sense. Yeah, it's a good point about matcha too, because you both have extraction going on, but you're also drinking the leaf that just happens to be so finely milled it's in suspension. Actually, I'm very curious to hear what you'll said later on about how it makes things slightly different.
I wanted to remark that it's actually very easy to make a water that brings out a lot of enjoyable characteristics from tea. And it's also very easy to make a water that totally masks unpalatable harshness and bitterness and astringency, like things that you don't want to taste. Off notes like funk. But the hard part is making a water that does both. And when I refine my mineral water recipes, that's usually what I'm working towards. It's a matter of preserving the good aspects without like bringing out additional harshness or off notes. And it's about minimizing that harshness without sacrificing the desirable qualities like sweetness, aftertaste, in some cases acidity, mouthfeel, stuff like that.
Got it. That makes sense. You just pull on the right levers. So, like, speaking of levers and variables for the way you would tweak water recipes, from my understanding, and this actually primarily comes from the coffee industry, where people talk about coffee water, like third wave water, like Lance Hendrick, like Scott Rao, Matt Perger. They all talk a lot about water chemistry, and they seem to talk about primarily dissolved gases, which actually I noticed on your blog you put like a lot more emphasis on than I've seen in the coffee world. So I'm curious to hear your take on that. pH, buffering capacity, and mineral content. And for any listeners it's been a little bit too long since their last chemistry class, buffering capacity is any solvent's ability to maintain pH. So like the human blood has a very powerful buffering system. For example, it's a bicarbonate-based buffering system. So if your blood swings too acidic or too alkaline, it has the immediate ability to bounce back to the preferable level to maintain homeostasis. So buffering capacity is something that you can play with to maintain pH levels more easily. So, is this how you view it as well, that these are the four primary sort of levers or variables that you have? And like, how does each one affect extraction and the way you prepare tea?
I agree that all of those factors are important. What I can't say are that there aren't other factors. I think there could be other factors like trace minerals, like stuff that you don't normally read on the sheet when you look at a mineral report. Basically, I just want to say like I don't understand the full picture, and I don't really think anyone else does either yet.
I don't think so
So
either.
these are four like really, yeah, these are like four really like prevalent topics when it comes to water, but there's probably more. That said, of those four factors, the one that I really know the most about is mineral content. When it comes to pH, buffering capacity, and dissolved gases, I think those could kind of be grouped together. Like they kind of go more hand in hand with each other, whereas the mineral composition is more like it's like what you're physically adding to the water. So I like to kind of focus on them a little bit separately. The thing that I know most about of those four factors is the mineral composition. When it comes to dissolved gases, I don't actually know too much about that. I just know that when I aerate water, it affects the pH, and that of course affects the buffering capacity. So um, I also know that CO2, carbon dioxide, is pretty relevant here. Um,
Mm.
because the way I make my water is basically that I dissolve limestone, chalk, calcium carbonate. So I have to carbonate the water after I add calcium carbonate to it. And that allows the carbonic acid to dissolve the calcium carbonate and like get it actually into solution. So the whole
Oh,
point of that is to get calcium content without the anions that usually go with calcium, which normally when you look at these DIY recipes, you're looking at citrate. In the case of third wave water, by the way, citrate does not occur naturally in drinking water. You're also looking at sulfate and you're looking at chloride. So sulfate and chloride do occur naturally in mineral water and they are essential. The problem is if you're depending fully on the chloride and sulfate forms, then like molecularly speaking, you're getting one ion of sulfate or chloride for every ion of calcium. And my rule of thumb is I like to get 1/3 to half of my calcium content from calcium carbonate, which means that I'm getting like um, half to only like 2/3 the amount of chloride and sulfate compared to the amount of calcium. So I'm just gonna dive straight into mineral content since that's the subject that I know the most about.
okay.
So let me just read them off a list. These are the main ones that I think about when I'm tuning a mineral profile for brewing tea. So, calcium and magnesium are the two primary flavor extractors. Calcium is more focused on sweetness, and magnesium is more focused on like savory or warmth or like umami. Then we have sulfate and chloride, which are the two typical anions that are, connected to calcium or magnesium. They kind of modulate the effects of calcium and magnesium. So, sulfate increases flavor definition and extraction intensity at the cost of bringing out harshness and off notes. Chloride, on the other hand, is like it's like a counter to sulfate. So it reduces the harshness and off notes that you get from sulfate, making the flavor profile more clean and palatable. But it also has the cost of like reducing depth. And so when your ratio of chloride to sulfate gets too high, you can kind of end up with a bland cup of tea that doesn't really taste like much. Then we have bicarbonate, which is, the buffer. The buffer is going to reduce the overall intensity in terms of how the water interacts with tea. It's also going to make the brew less acidic, which means, you're going to get less sourness in your mouth. More buffer also tends to reduce top notes, making everything taste bassy, especially when used in high amounts. And lastly, sodium and potassium are going to be relevant because, we have sodium bicarbonate as the source of bicarbonate, and we have potassium bicarbonate as the other source of bicarbonate. Well, I mean, there's more than just those ways to get bicarbonate, but in terms of like dedicated buffer, like what one mineral would you pick to add buffer to water without like affecting other stuff? You would tend to choose mainly sodium bicarbonate with maybe some potassium bicarbonate as well. And to explain the differences between sodium and potassium, you can think of sodium as kind of warm and sweet, while potassium is more like cold and bitter.
Mm.
So, looking at reports of natural mineral water, you'll find a trend. Generally, there's a lot more sodium than potassium, and I think that's kind of a good thing. I don't know why it is that way. I don't know what's causing a higher sodium content in water compared to potassium, but I know that when I follow like these artificial DIY recipes that demand lots of potassium in the water, basically you get like weird effects that kind of come across as very artificial and just not very palatable. So I
Mm.
prefer to when I'm incorporating buffer into the water, I prefer to lean heavily on sodium bicarbonate and only include a tiny, tiny amount of potassium because I find that it kind of saps away sweetness when you have too much potassium in the water. So I only like about 1 or 2 milligrams of potassium at most in the water.
Okay, interesting, fascinating. Actually, zooming back a bit, um, it when I was reading your blog, is the first time I ever heard of anyone carbonating and then decarbonating water. But I guess it's just for the purpose of dissolving the calcium carbonate. Is that a technique used in coffee, or how did you come across that? I've never heard of anyone doing that before. Sounds very labor intensive.
Um, it is kind of labor intensive, but I'm not the person who thought of it. I don't think there is like one person who can take credit from it because I know people in the tea sphere who have been doing it without really talking about it much. Um, I know Max from Tea Secrets. He's the guy that kind of incentivized me to start using it. Um, but that said, there's a coffee blog called Grind Science,
Hmm.
and the author of that blog is the first um, that I've seen personally that like it it goes back the furthest from anyone I know using calcium carbonate in water.
And it when you add the calcium carbonate, the pH rebalances because you're going to create a lot of carbonic acid when you carbonate it.
Yeah, so that's one of the problems with using calcium carbonate. Like it's not really a problem, it's just like an obstacle that you have to deal with extra labor. So here's the process basically. So you're going to add your minerals to deionized water. That mix of minerals and water is going to be in like some sort of pressurized container, like a keg or a soda stream bottle. Then you're going to carbonate that with CO2, and you need to like agitate that and wait for a couple days until it's fully dissolved. So once that's fully dissolved, and you actually do have to check that it's fully dissolved, because if it's not, then that tiny, tiny amount of undissolved mineral that's floating around in there, which is chalk, because everything else dissolves pretty easily, that little amount of undissolved chalk that's just like floating around as a suspension, that's basically going to kill flavor.
Oh,
So I don't know exactly how it works. I think it just kind of gets on your tongue and mouth and like
Yeah,
just occludes your taste buds. That's my theory. I don't know if that's backed up by anything, but that's how I interpret it. Um,
it must have
because
a texture too, like it's a powdery texture. Your tongue might be
it
able to.
might, if there's enough that's not dissolved, I think you would feel that. But the amounts of undissolved chalk that can actually ruin a batch of water are far lower than what you would physically feel in your mouth. It's like a really small amount can still um like occlude flavor. So
interesting. Like home kettle, that's full of those calcium pieces, the ones that sink to the bottom, the ones that float up to the top, right? Likelihood is that there is some like small amounts of calcium carbonate or chalk in that water that are suspended around, really killing a lot of flavor.
I think that is partially the case. Uh, Actually, can we come back to this in a sec? Because this is actually a
Sure,
really interesting topic. But I wanna finish the formulation process so that everyone knows how it's made.
sure.
Um, so you had a question about like what do you do with all the extra CO2? So once you carbonate that batch of mineral water, um, and everything's dissolved, let's say you check the bottom of the container, you make sure like nothing's sitting down there, looks perfectly clear. You compare to a bottle of clear water so that you're absolutely certain it's like 100% dissolved. Then you're ready for the next step, which is to get rid of all that extra CO2. And the way I do it is I just stick an electric mixer in there and I just mix it until like all the extra CO2 is, gone. from the water. It just takes it out of solution, and it takes, I don't know, half an hour up to 2 hours, depending on the size of the batch.
Oh,
And
wow. Okay.
Wow.
once that's done, yeah, it uses a lot of energy, takes some time, but once that's done, you have water that just tastes like normal water rather than like weird soda water.
Interesting. So
And
when you
some people think that if you just boil the water, you'll get rid of any of that soda flavor, because like boiled water is said to like release all of its dissolved gases. But personally, I don't know what the reason for it is, but that just isn't the case. If you boil soda water, it will still taste like soda water, maybe because you have to boil it for a way longer time period.
Interesting.
Sam, what was your question?
Yeah, I'm sorry. So after you purge all of the CO2, or even if you end up boiling the solution, won't all of the calcium carbonate recrystallize?
Um, so uh, that kind of depends on what the concentration is, because when you boil water that has calcium carbonate in it, naturally some of it is going to fall out of solution. That is the case, but
Okay.
in this case, empirical water is pretty low. Low in TDS. It's like 70 milligrams per liter in total, and only like a fraction of that is calcium carbonate. So the amount of calcium carbonate that's dissolved in the water is gonna directly impact also how much of it falls out of solution when you boil the water. So in the case of empirical water, if you I'm actually looking at the inside of my kettle right now. I know you can't see it right now, but I'm just going to tell you what I see. This kettle has been used with empirical water for maybe like a year now. I clean it like roughly once a year, but it's just like for no reason, right? It's just to like see what happens when I start using water in it again. I just
Mhm.
see like faint white dots at the bottom. I mean, not even white. They're just like spots where the stainless steel in the bottom of the kettle doesn't look quite clear. So what that's telling me is that, um, and also this is backed up by the Langelier's saturation index, which is a calculator that tells you how saturated with calcium carbonate your solution is. This is basically telling me that a small amount of calcium carbonate is falling out of solution when I boil the water, and then when the water cools back down again, the water is actually undersaturated with respect to calcium carbonate, because calcium carbonate um, becomes less soluble as you increase the temperature, and of course more soluble as you decrease the temperature.
Mm.
So basically what's happening here, and it's the same thing inside my espresso boiler, it's that um, you boil some water, you might notice that there's like faint white spots in the bottom of your kettle, and then that residue just gets eaten up by the water as it cools back down. So it's like a zero sum thing, like it just gets reabsorbed.
Very interesting.
That makes sense. It's interesting that you say that. You know, at the Tea Institute at Penn State, back when we were there, I guess 10 years ago, we had cast iron tetsubins, or the that were unenameled on the inside, so the water was in contact with the iron. And there's always a layer of calcium. And whenever we changed water to sources that were like really soft water, I'd noticed that some of that calcium would disappear. And it was interesting that it was like always being reincorporated into the water as we changed water sources. So I've empirically noticed that in the past. So it's interesting that you say that too.
Yeah, I actually have a Tetsubin uh, right next to my stainless steel kettle on my desk. It's always here on its hot plate, and actually looking inside it, I see some rust, um, which, of course, has its own effect on the water. Um, and I see faint lines of calcium carbonate, uh, like when the water level gets low, and basically, um, like the amount of surface area where the water is evaporating is much higher compared to the volume that's in there. At that point, you see the lines of calcium carbonate start to form around the bottom of the inside of this kettle. But it's very faint, and just as you noticed, when you fill it back up, especially when it's cool, right? It reabsorbs that calcium. If it's the case that that particular water is undersaturated in calcium carbonate at a lower temperature.
It's like a self-correcting like little ecosystem inside the tetsuba or in any kettle.
That's pretty amazing.
I should mention it's not like a constant across all different waters. Some waters are just more saturated with calcium carbonate, and the amount that falls out of solution when you boil it is just never gonna get reabsorbed as the water cools. So this is something that's kind of unique to softer waters that have calcium carbonate in it, and it doesn't happen with all water.
So a lot of our listeners either order matcha at their local coffee shop, or have been exposed through it through specialty coffee, or own specialty cafes themselves. So water that's been optimized for coffee, how good is that generally for preparing tea versus coffee? Are they generally in agreement, or should there really be recipes that are better suited for tea than for a coffee program?
So this is kind of a complicated topic, but I'll do my best with it. Um, so with tea, you have certain constants, right? Like the leaf is not gonna get ground other than matcha. So you're dealing with whole leaves, and so that means you need a water that is actually powerful enough to like work its way into the leaves and bring stuff out with it, to extract. And the surface area of like tea leaves, like when you have whole tea leaves, is a lot lower than like with coffee, because with coffee you're grinding it and you can pretty much grind it as fine as you could possibly need to, which not only increases surface area, but it's vulnerable surface area, because it's like broken apart, like the cell walls are all broken up. So it's a lot easier. It can be a lot easier to extract coffee than with tea. On the flip side, with tea you can't decrease the surface area, whereas with coffee you can just grind it coarser if your water is too intense. So what that basically boils down to is that with tea, you need kind of a constant amount of buffer that isn't really going to change depending on the tea, unless it's heavily roasted, which is kind of just like coffee, but it's not as common for tea to be roasted that heavily. So with tea, basically like really dark oolong roast and matcha aside, you need a really constant amount of buffer that's not going to change. If you have too little, then you're going to have to just reduce your water temperature, so that you're not bringing out like a ton of harshness every time you try to steep your tea. But if you have too much buffer, you're kind of screwed, because there's just no way to get more out of the tea. Buffer is going to reduce the intensity of the water's interaction with tea. And so when you have too much buffer, you're kind of dealing with bland tea where you just can't get enough flavor out of it.
That's interesting.
Might actually reduce the
And then-
definition of the flavor profile. You won't be able to taste
Yeah.
much.
Exactly. And with
never thought of
coffee, you do have the option. Sorry?
Yeah, I've never thought of it. That's interesting. So actually, more like matcha or roasted, like oolong profiles, would generally be more suitable towards optimized coffee water than, let's say, like loose leaf green tea or a very green oolong.
Yeah, and with those types you mentioned, dark roasts of oolong and matcha, generally you can use a lot more buffer there because it's just so much easier to extract.
Interesting.
So with coffee, you have different roasts. It's a lot more common to be dealing with dark roasts. And you also have espresso, which is like a very, very fine grind. So there you have the option to use a lot more buffer. And you can pretty much use the same water for light roast coffee as you do with tea. That I would feel those two kind of categories from coffee, light roast coffee and, generally whole leaf tea that isn't roasted dark. I would say those two categories use pretty similar water.
Interesting. I like that classification too. That makes it like very easy to apply that knowledge. Like pour over for and more lighter, delicate teas, and then matcha roasty teas for more like espresso type extraction water. That's really fascinating. Have you tried any of the like new trendy alkaline waters? Like if you look at like any of the water chemistry extremes, like if you take these alkaline waters and use it to brew tea, like what generally happens with a high alkaline water?
So I do have a bit of experience with this, not a lot because my initial experiences were never positive. Um, but I feel that once you get above like 8.5 pH, things start to turn I don't want to say sour, but maybe bland.
Mm.
Above around 8 pH, 8 to 8.5 is really like the highest you can go with tea because as I mentioned, you can't really increase the surface area of your tea. I guess, the thing is if you're desperate, you could break up your tea leaves and then you would have more surface area to work with. But I think most people don't do that and would never think to do that, so they're going to rely on the water. An experience I had recently with very alkaline water was actually a recreation of my own water, empirical water, where I swapped out calcium carbonate for molecularly equivalent amounts of calcium hydroxide. The thing is,
Oh,
you'd never want to put a hydroxide on an ingredients list, even though you can process it to behave chemically identical. So basically, you can recreate empirical water without the carbonation step by using a molecularly equivalent amount of calcium hydroxide. And then rather than carbonating that, I mean, that's just going to dissolve fine on its own. But then if you try to brew with that water, basically the problem is that hydroxide is making the water way too basic. So you're dealing with a water that's like, I don't know, 11 in pH, which is
Ooh.
just way too high. And when I tried to brew with that, it was bitter like nothing I had ever experienced before, except maybe like what is that spiral detox tea? Do you know what I'm talking about? It's
like
like
kuding?
kuding or something like that.
Kuding,
Yeah, it
kuding
tasted
cha
like
is
that. It was terrible. So if you want to recreate empirical water without the whole carbonation step, well, basically you have to use calcium hydroxide, but then you still have to do the decarbonation step, which is like to use an electric mixer, which is gonna agitate the surface of the water, and then you're gonna incorporate atmospheric CO2 into the water because there's actually not enough in there, and it's too basic rather than acidic.
Ah, oh, that's fascinating. So I guess the short answer is anyone who is committed to alkaline water lifestyle, so definitely not to use that for tea or coffee.
Unless you want to drink
Yeah,
cooling
probably
cha.
not.
Cool. Could you talk a little bit more about your iterative approach? Like anyone who goes through your website, it's like super cool because you give release notes and you keep iterating on this recipe. But
Yeah,
like,
it's like making water software.
yeah,
It's pretty cool.
Yeah, the whole software thing was an inspiration. I do want to kind of change the perception of mineral water for coffee and tea. Because right now everyone is like starting to get really like in the know with like in-depth processing methods of tea, like rolling steps, oxidation steps, fermentation, all this different stuff. But I feel like no one's really like peeled back the veil, like peeled back the layers on water. So, looking back, I wish I had written more, really. I really could have written more because these versions that you see here, August 7, 2022, the release of Untitled, which was before this water had a real name, like you go from there to like April 22, 2023, and then you see the notes. It concentrates the desirable flavors more than ever without running into harshness. Now suitable for use in espresso boilers. Top notes have taken a step back in the mix and will be given a boost in the next iteration. Slight boost in mouthfeel. Like these are all changes that basically if you were to try your hand at making those changes to go from like the August 7 version to the April 2022 version the next year, it would be like trying to guess like a 8-character password like through brute force. So it's like it's not something that you can just decide. Like you can't just decide I'm gonna increase top notes and then do something to increase the top notes and then just have the water work. When you change something, other things break. So it's like this triangulation where instead of having 3 points like a triangle, you have like 8 different points. So when you move one thing, you have to adjust everything else around it to make it work. So I guess the process is like it's pretty much centered around ratios because that's how I think of water. I think of it in terms of molecular ratios. Let me just open up my water calculator right now. You can actually find the spreadsheet that I use, and you can download it and edit it yourself if you want to like modify it in any way. If you just search empirical water open source on the internet, it will be like the first link that pops up. You'll see it in the article. You can click that button, download the spreadsheet, and then you can just edit it yourself. So I'm going to open up that spreadsheet right now and read out some numbers. So the current version is it pretty much has fine-tuned a bunch of things that I don't think will change. And that's what I want to talk about right now, because I think these are the fundamentals that if you just want a water that works, you can pretty much just follow this and it won't like break anything. You can kind of just rely on these as constants. The first thing is the calcium to magnesium ratio. And before I get into this, these are all molecular ratios. It's like in terms of the number of molecules of each ion. It's not based on weights of the minerals because, for example, like sulfate is going to have a different weight than magnesium. So when you say I'm going to add like 1 gram of magnesium sulfate to this concentrate, you're not going to get 500 milligrams of magnesium and 500 milligrams of sulfate, even though the number of ions is the same. So I prefer to think of these ratios, I prefer to think of them in numbers of molecules. So starting with calcium to magnesium, so going back to the descriptions of each molecule, calcium is going to add sweetness. So we want sweetness dominant water because generally sweetness is like what everyone looks for, right? Like in matcha, you want a ton of umami. So maybe matcha is like an exception. Japanese teas might be an exception where you actually want something magnesium dominant, but like for the vast majority of tea and coffee that's out there, it's going to make sense to go for a higher calcium. So the ratio that I use is a 2-to-1 ratio of calcium to magnesium. You can increase that to 3-to-1, or you can decrease that all the way down to like 1.5-to-1. But that's kind of the window. 2-to-1 is like should be seen as kind of like the default that you should work with because you're getting plenty of sweetness from calcium and you're also getting plenty of warmth and savory and umami characteristic from magnesium. Then we have the chloride to sulfate ratio. These are the anions that are going to come with calcium and magnesium, and that's also going to be a 2-to-1 ratio. The calcium to magnesium ratio is pretty forgiving, whereas the chloride to sulfate ratio is going to be a lot less forgiving. So in my case, I'm using a 2.13 to 1 ratio of chloride to sulfate. And going back to the descriptions of each ion, the result is going to be a dominance of the smooth, clean characteristics of chloride over the relatively restrained intensity of sulfate. So having a 2-to-1 ratio of chloride to sulfate is going to get you that clean, sweet flavor without the excessive harshness and bitterness of sulfate. But there's still enough sulfate to get you like pronounced flavor notes. And that's the role that sulfate plays. It's to take the stuff that calcium and magnesium extract and make it like pop when you experience it, so that you're not thinking, this tastes kind of green. You're thinking, this tastes like a specific kind of grass, or like parsley, or something particular.
Like increases resolution.
Then we have, yeah, exactly. That's exactly what it does. It increases like definition. It increases resolution. And when you have too much sulfate, let's say I were to use a 1-to-1 ratio of chloride to sulfate compared to 2-to-1, then the result of that, if it's not accounted for with like an overall reduction of intensity, let's say we keep everything else constant and just use more sulfate, the result is going to pretty much be like a ton of off notes that you have to kind of brew around. So instead of having the flexibility of brewing your tea really strong or really weak, however you want, the sweet spot kind of closes in on you. And eventually, if the mineral profile is too far off, there's no real sweet spot where like everything you brew turns out bitter. And I think that's when I say that water is the bottleneck, that's what I'm talking about. Like a lot of people have water that they think is okay because when they drink it on its own, it tastes fine. But then when it actually interacts with tea, all you get is like bitterness and like just a bland sourness and stuff like that. Like when people post on Reddit or any other forum, I can't get my tea to taste good. Like that's what I want to yell through my screen, that like, dude, there's nothing you can do if your water is holding you back. Like the game is rigged against you. You got to change the water.
Yeah, that's so true. Like a lot of the tea people end up, traveling with their tea from their hometown and can never get the same flavor profile
Yeah.
when they're trying to brew tea elsewhere. Frequently, it's because of the water.
Yeah,
Like,
or if you buy it, you got a sample of it. Like, let's say you're in mainland China or Taiwan or Japan. You're like, oh, this tea tastes amazing. You bring it home, and you're like, this isn't what I bought.
brew with central Pennsylvania water.
Yeah, it's
like,
the
wow.
worst.
Yeah, that's
Absolutely.
quite fascinating.
Yeah, and you got to take stuff like that, experiences like that, you got to learn from it. Because the tea doesn't just change overnight. It doesn't just go from being a great tea to being a poor tea the next day. So yeah, definitely got to pay attention to what water you're using. And if you can, if you find a source that you really like, let's say a natural spring that maybe you have to travel to, or a bottled water that normally in your country you don't normally get access to, what you should do is you should bottle that up and you should send it to a lab. Now, the lab that I'm going to recommend does this pretty cheaply. They're called Ward Labs, and they only charge about $50 to analyze the full mineral content of your water. I'm not affiliated with them in any way, but I have used the service a few times, and it has absolutely saved me and helped me figure out what's in some really good waters that I wanted to take some strengths from.
Oh, cool. That's cool.
Yeah,
And then you can recreate that.
That's fascinating because, like, sometimes when you can sometimes even say that a certain type of tea evolves with the water they have in the locality. it goes both ways. So it's not just the water is making the tea taste good in the area, but also it's the tea maker that trying to create this flavor profile because they only have access to those water.
Some
Uh,
coevolution.
it's a co-evolution. So I think it would be
Absolutely.
very beneficial to be able to recreate a water composition from a location, specifically coming from the tea that you want to drink. Um, I think that would be very cool.
Yeah, I think one of the topics we were going to cover is like how does the water in a particular, locality affect like the resulting tea in that region? How does the water that's used to grow the tea affect the actual tea that's brewed? And
Mm.
also, what water should you be using to brew a tea based on what water was used to grow the tea? So,
Mm.
those are some pretty complicated topics, and I think the answers are not really available. But I think that there is some kind of speculation that we can do just using common sense. So I want to say right off the bat, I actually have no idea if there's like some sort of benefit to be gained from mimicking the the water that was used to grow the tea in order to brew the tea. Like I don't have any scientific um, understanding of that. I don't know how the mineral content of water in the growing process affects the actual resulting tea. That said, um, I think that the variety and different waters that you'll find chemically is in a way greater than the variety in potential tea that you can find, as crazy as that sounds. I mean,
Mm.
after all, tea has all kinds of different flavors in it that, I mean, you taste a tea and sometimes you don't even think that this is tea because it's so vividly flavorful and reminds you of something else. Um, and as true as that may be, I still think that um, water has like more variety in it than um, than you would have to account for when selecting water to brew the tea. For example, like you could have a region that like naturally just has super low TDS water, like 20 milligrams per liter, and that they might use that and make and grow incredible tea with it because the mineral content may not be coming from the water, but it is already present in the soil where it's being grown. So it's like
That's
really
a
hard
good
to
point.
track these things. And then let's say you take that tea and you try to brew it with 20 TDS water. Well, it's like how do you know that that's the best water that like how do you make the assertion that oh, that's the best water to brew this tea with just because, you know, that was used to grow the tea whereas like some of the mineral content could have just come from another source and possibly even had no impact on the tea. So, it's really hard to tell. Yeah, it's hard to answer that question. That said, I think one thing you can really track is like the different tea styles that come from different places, like different processing steps that they might use. The rolling of the tea is going to affect like how much the cell walls are broken down, and you might be able to track um, like a correlation between the intensity of the water available and the intensity of the rolling, where I feel
Ah,
like there could be an inverse correlation because um, when you have a more intensely rolled tea that's easier to extract, you also want a water that is less intensely extracting because you don't want an intense water to overpower an already intense tea and like bring out an extremely strong brew that is not so palatable. You want
Yeah,
one to balance out the other.
yeah. The way the tea gets processed, not just rolling, but also maybe roasting too, might
Yeah.
be affected by the water that are available in the locality. So,
yeah. Maybe that explains a lot of the regional differences.
yeah,
Like
there
it,
there could be a very interesting research on the geoscience or geology of the location with the tea style
yeah,
in the location. That would be very cool, I think.
Yeah, are you guys familiar with the Chaozhou style of brewing oolong?
Yeah,
Very
yeah,
much so. Yeah,
yeah.
So
Denso.
where
it's
you
like
crush it?
super intense. Yeah,
Yeah.
exactly. It's super intense. So if I was to make a guess, I would say that wherever that that style of brewing originated from, I mean, I think it's called the Chaozhou. I actually don't know the name of the place. Is that it?
Yep, that's
Yep.
it.
Chaozhou.
Chaozhou.
Chaozhou?
Mm-hmm.
Yeah. I would assume that um, their water is pretty soft and pretty gentle in terms of how it interacts with the tea. So then they can use that water and extract their tea, with a pretty intense method and still get something that's palatable out of that.
Yeah. Yeah, for anyone who's listening that has never heard of Chaozhou Gongfu Cha, it's a really updosed tea, typically oolong, typically something like a dancong. And they crush usually about 30% of it. They take whole leaves, they physically crush, and then 70% are whole leaves. So you greatly increasing surface area. So that's really interesting. So where do you see the future of water chemistry, optimization, water recipes for tea evolving? Like we're still like super in the early days. Like it wasn't until like 5 years ago you started to hear people talk about this for coffee, and for like tea it's even more new. And like empirical water, like you seem like really on like the front ends of research on empirically testing, to see to what extent you can improve water for tea by testing these different variables. So, like, what's the areas of research that you're most interested in continuing and using to improve and update these water recipes?
So just really quick to put this in a sort of chronology. Here's my understanding of it. So at first, people just used whatever water they had available, like tap water, and often filtering that tap water in order to get rid of like odors, chlorine, stuff like that. Um, Activated charcoal, um, the usual suspects. Then RO became more commonplace, and
Hmm.
I think some people still use that, and it can be good, although it's not very versatile. For example, with Chaozhou style brewing, I think RO would work fairly well. After that, that's when we had the artificial, like dry mineral packets, which I guess I probably shouldn't name, but we know what they are. If you just search like water for coffee or something, the usual brands will come up. Uh, that is like that's the precursor to what I'm doing. It's the precursor in the sense that they rely on mineral profiles that you can just dissolve without any extra steps. Um, and there are limitations to that, which is basically the excess uh, citrate, which is not naturally occurring in water, the chloride, the excess chloride and sulfate. Uh, so the current step that we're at now is to reduce that excess chloride and sulfate by taking hints from naturally occurring mineral water, and that's the use of calcium carbonate. So the question is now, how do we take this kind of format that's come full circle with nature, and how do we take that further? So the main thing right now is just not looking too far forward and just focusing on making the most out of the existing, methods and techniques, which is like the carbonation and all that. So right now, empirical water is 70 milligrams per liter in TDS. It's kind of on the medium light side. Now, I think there's room to go even lower. You can go lower than 70. I think you could go as low as really like 20. Um, and you can also go a lot higher. So I think the range that you could really explore is around between 20 milligrams per liter of TDS up to all the way up to like 500 milligrams per liter, which is, pretty high.
Big range.
When you, yeah, when you get up that high, you're basically dealing with water that scales. So that's like a kind of no-no for some people. And you can even encounter scale as high as like 120 milligrams per liter in total. Um, So that kind of puts a cap, like based on who you are and what your needs are in terms of like convenience and like not having to clean stuff. That kind of puts a cap. But if we kind of like disregard those people, not that there's anything wrong with that, but just if we just prioritize the quality of the resulting tea over all else, then I think really the next step is exploring that TDS range between like 100 up to 500. That's like the main thing that needs to be looked into, because I would say my most uh, like significant and even like whimsical experiences with tea have been with water in that 100 to 500 range. Obviously, it's not convenient. Um, you have scale, and also you can't concentrate it that much. Like if you look at the total mineral content that I'm able to fit into empirical water without it precipitating and like losing its positive qualities, it's like almost exactly 1,000 milligrams per liter. If you're just looking at the concentrate, um, like let's say you're working with a water that's up in that 500 range, that like you can only concentrate that to a 2x, which means that's super inconvenient and super inexpensive. That's where I think DIY comes into play, because no one's really going to be willing to pay for water that you can only concentrate as a 2x and can't be sold as a mineral packet. So what I want to see is mineral water becoming a much more local thing where you don't have to worry about shipping. I want to see mineral water being sold for tea and coffee in a ready-to-use format, meaning you just pour it out of the bottle and into your kettle. And in that sort of range of 70 or 100 to 500, I want to see like completely different approaches to making like a palatable mineral profile. So let's say you take my existing mineral profile and you change, like, let's just say you flip the chloride to sulfate ratio. Now, that will make the water pretty bad, but there are ways to account for that by changing other things. So you could get a completely different experience and still very good if you flipped, let's say, that chloride to sulfate ratio and then accounted for the increase in intensity by reducing the ratio of hardness to alkalinity, which basically just means increasing across the board the amount of hardness you would reduce the ratio of hardness to alkalinity by reducing the amount of hardness minerals and increasing the amount of buffer. So the point is that if the next step isn't really to change one thing and be like, okay, that's going to make water better. It's really to just throw out some constants and then adjust everything else around those changes to get a completely different but still generally applicable and enjoyable mineral profile, anywhere in the range of like 70 to 500 TDS. That's where I think water is going.
Well, that makes sense too.
Stronger and harder. That's the future.
Well, it's exploring tea on dimensions that people like haven't really explored it in an intentional way, which is pretty cool, because who knows what we'll discover.
Yeah, it's part of the beauty of all the specialty beverage movement is to have all these available options for you to explore.
Yeah, exactly.
Yeah, I like to think of water as a lens. So or like as a filter. You know how on Instagram when you're about to post a photo, you can like choose any filter?
Yeah.
It's kind of like that. Or it's also like the headphones that you use, or the stereo system that you use to listen to music, just kind of presents it in a different way. Although in the case of tea, it's like much more dramatic than that.
Yeah.
Like you can taste flavors that you just would never otherwise taste.
Yeah, it's like different
So,
style
yeah.
of amplifiers, so tube amplifiers.
Yeah.
You can have a lot of different results.
Yeah. Except in music, right? You pay a certain amount for any music, but in tea, and when you're paying $1, $2, $5 a gram for a matcha, right? If you're using low quality water, you're just wasting money because you're not even expressing those sounds. You're not expressing those flavors. So we really urge anyone who's into specialty matcha, into specialty tea in general, to pay extra careful attention to their water and to visit Empirical Water and their website and all of the resources that they have to improve your water chemistry and the experience that you're going to have. Because ultimately, if we don't enjoy what we're drinking, then what are we doing?
Thanks for having me.
Thanks for coming on. So I think that's all we have time for today. So thanks everyone for listening, and thank you, Arby, for joining us. If you like this podcast, please share it with a friend. Consider giving us 5 stars, and we'll see you on the next one.
See you in the future.
Take care.
Bye.